Hello, my name is Dagny Battaglino, and I'm going to talk to you about pH, what pH means, how we can test pH, and what we can learn from pH. I am majoring in civil engineering at the University of Portland with a minor in environmental engineering. I am from Katy, Texas, and I plan on in my career to bring a sustainable and environmentally conscious design to all of my projects. So what is pH and how can you test it at home? pH is the concentration of positively charged hydrogen ions in a solution. That means how many hydrogen ions are floating around in a solution per volume. Well, this is normally a very small number, so to get a better representation of this value, we use the pH calculation. It is equal to the negative log of the concentration of hydrogen ions. pH comes in a scale from 0 to 14 and tells us how acidic or basic something is. 0 to 14 is a lot easier to understand than very small hydrogen concentration numbers. Low pH values mean that a substance is acidic. These low pH values correspond to very high hydrogen concentrations in the water or substance. Large pH values mean that the substance is basic or alkaline and correspond to when there is relatively low concentration of hydrogen. But just in the middle, at a pH of 7, the substance is neutral. This is most drinking water. You don't want to be drinking acidic water, and neither do fish or plants, which is why testing pH is important. We can sample water from different environments and see if it is going to be harmful to the living organisms there. This information can be used to try to remedy the pH imbalance in the environment. But first we need to know what the pH is. Now, if you were a fancy scientist out in the field, you would do it in a bit of a different way. But the fun thing is you can do it at home by taking advantage of a chemical in purple cabbage called anthocyanin. This chemical is pH sensitive and means that it will change color when the concentration of hydrogen changes in a predictable way. Now on to the experiment. What you will need: a purple cabbage or a red cabbage, a nice pot, water, a cotton cloth, and then finally the things you want to test the pH of. Now what you do: you're going to chop up your cabbage very carefully, put it in a pot and cover it with water. Then you're going to cook that cabbage on medium heat for 2 hours. You want all of the pigment from the cabbage to move into the water. The pigment is where the chemical that we talked about lives. Now, once it is thoroughly cooked and your house smells like cabbage, you're going to remove it from the heat, let it cool, and remove the pulp. Now you should have a very purpley liquid. You're going to separate a portion of that liquid, add vinegar, and see what color it changes to. Now, this particular chemical will become more pink or lighter in something that is acidic, and it will become more blue or teal in something that is basic. So have some fun testing around your house. I recommend starting off with something that you know is going to be acidic, like vinegar, and seeing what color it changes to. And then moving on to some other things that you don't know whether or not they're going to be acidic or basic, and seeing what color they change. Also, no change is totally an answer. That means pH neutral. Now, my most favorite part of this experiment is that pH-sensitive purple liquid that you made is actually a dye bath. All of that pigment that you separated from the cabbage can be used to dye cloth. So you'll want to make a color that you like by taking your purple liquid and either adding an acid like vinegar or a base like baking soda to get a color that you like, and then soak your cloth in that dye bath for at least an hour. But you can see that this teal was made by adding baking soda. The purple in the middle in the left left picture was made by just leaving it as is, and that pink on the right picture was made by adding vinegar. So have some fun, dye your fabric, and see how the pH changes when you add weird and different things. Thank you so much. If you dye some cool things, send pictures to that email below, robotics@up.edu. Thank you so much for watching.